Okay. Good afternoon, everyone. Everyone had a good lunch? Everyone's going to stay awake. This is the least coveted spot for a speaker, is just after lunch when everyone's a little bit dozy and you just want to have a rest. I'll try and keep this really interesting and exciting for you. So my name's Steve. I'm a Microsoft MVP. I'm a Pluralsight author. I'm a senior developer for a company called Madgex. We're based down in Brighton, which is in the UK. And we do software as a service, mainly recruitment products, so digital job boards, digital job board platforms being our main product that we do for a lot of the large media brands. In the UK, that's people like The Guardian and The Telegraph. In the US, we have The Washington Post that run on our platforms. Also, I run a meetup group down there called .NET Southeast. So if you ever find yourself in the south of the UK by any chance, and it happens to be on the right day of the week and the right month, come along and do join us. We're always looking for more people to come along. You can find my details there. So my Twitter handle, do feel free to tweet me questions after the talk if you don't get to catch up with me. Do also follow me, that's always great. Take photographs so I can show my family what I'm doing with my Saturday in the Netherlands. I'm sure they'll be really impressed to see me doing something so exciting. And my blog there, so a lot of what I'm going to cover today I have blogged about previously, particularly the internals of HttpClient and how HttpClientFactory works. So we're going to look at all of those, but if you feel that you want to get any more detail, recommend you check the blog first and see if that answers your questions and gives you the detailed code that you want. And also the slide link is up. This is live now, so these slides are all online. If you can't see anything and you want to follow along on your phones, you can. And you don't have to take photographs of every other slide. As long as you've got this one, you're kind of good to go. So the motivation and the reason that I wanted to start talking about HTTP was at Madgex we were doing a lot of work with starting to build out new systems that were microservice based. And while some of that communication we can kind of do asynchronously over queues and message buses, there's still a portion of that we need to communicate between services in real time. And so we're typically going to look at using HTTP as our way of doing that. So we're kind of doing REST. It's JSON over HTTP is really what we're doing most of the time. Our services are communicating in that way. And there are other ways of doing communication that are coming along. So gRPC is coming along in 3.0, and that's a new way of considering how you might do server-to-server communication. And I know Mark's doing a talk on that later on, just after me, in fact, if you're interested in that. But it's really important, because we're doing a lot of this communication and we're making more and more calls between services, we really do want to get the HTTP piece right, and we want to do everything as efficiently as possible, and we want to be as resilient as possible, so that we make sure that the applications that we're deploying all work well together. So that's kind of the motivation for this talk and what I'm going to try and focus on over the next 45 minutes. So briefly, what we're going to cover, I'm going to begin with talking about IHttpClientFactory. So this was introduced with the ASP.NET Core 2.1 release, and it's a feature that we'll see has a number of nice advantages. So we'll talk about why we need it and what we can do with it, and we'll see some examples of how we actually begin taking our code over to that. We're also going to talk a little bit about the idea of outgoing middleware. So if you're familiar with ASP.NET Core, hopefully you're familiar with the ASP.NET Core middleware pipeline. Requests come into your application, they flow through that pipeline. Eventually, one of those middleware components will return a response, which then flows back out in the reverse direction. We can do a similar sort of thing for outgoing requests. So if we have any kind of cross-cutting concerns that we want to apply to our outgoing calls, we can consider using this middleware as a way of applying that. And we'll see how we can do that and how HttpClientFactory makes that easier. We'll talk a little bit about transient error handling. HTTP is a transient, or is subject to transient failures. Servers go down, services move, network packets get lost. So we need to deal with that in our code. And Poly is a library that we can integrate with to do that very easily. We'll talk a little bit about other HTTP tips and tricks, patterns, just things to watch out for in your code, things to check for code reviews to make sure that you're not doing anything that might compromise your applications. And we'll also briefly talk about some other changes that came in .NET Core 2.1 and what's coming in 3.0. I am generally talking about Core, so .NET Core today. A lot of this is pretty much applicable in .NET Framework, but the implementation details do differ in some areas. So, if you're working in just .NET Framework, hopefully most of this advice is good, but just check that it still applies where you're working. So we're going to start with some code. Hopefully everyone can see this. I'm doing all the code in slides, so there's no jumping around. So we're going to start with this code. This is just a very trivial HTTP call that we're going to do. So in this case, I'm inside a controller. So imagine this is an ASP.NET Core web API. I've got a controller, and I've got an action method that needs to communicate with a downstream service, in this case, the GitHub API, to get some data. So in there, we are making a call. We are getting the data back, hopefully. We're deserializing that data, and then we're passing it back as part of our response to our caller. So we're going to look at this code through the rest of the talk, and we're going to see how we can refactor this and improve this and some things to watch out for. But before I move on, and there's no shame in this, how many people have got code that looks quite similar to this in code bases today? Yeah? Okay. So there might be some homework, possibly, depending on what you take out of this talk. So let's dig in and see what potential problems are in here. The first one, and the elephant in the room when you talk about HTTP client, tends to be the use of sort of using statements around it and whether you should dispose of it or not. We'll wrap up near the end with more discussion on the iDisposable specifically, but I want to talk about why this could be problematic depending on your scenario. So what's actually happening here is HTTP client itself implements iDisposable, and so this looks perfectly reasonable as a developer. We've got an iDisposable interface on a type, so we're going to get rid of it when we're done with it, in this case at the end of the action method. But the problem with this is HTTP client only implements iDisposable because it has a reference to a HTTP message handler chain, which itself is iDisposable. And the reason that is iDisposable is because at the end of that handler chain, we have to have a network connection somewhere. We're going to actually make a call. And so we've got that OS connection open to some downstream server that's the unmanaged resource, in this case, signaled by iDisposable. Now, depending on what you're doing and where you're using this may be reasonable. If you were doing this once or twice at the start of your application just to get some data that maybe configures your application, this would be fine. But in this case, we're doing it in an action method. So this means this is getting called very, very often, potentially. If this is a busy website, maybe hundreds of times a second through this action. And so what we're doing is we're continually creating this new HTTP client, new handler chain, new set of connections in the connection pool. We're having to establish those connections, so there's essentially a little bit of performance there if we do the TLS handshaking that needs to go on. And then when we're done, we're just closing that connection. Now, if we close the connection and it was immediately freed, that would be great. But what actually happens in the TCP spec is that when we close a connection, the OS doesn't immediately release the port that we were using back to the pool of ephemeral ports. It keeps it in what's called a time-wait state for a period of 240 seconds on Windows. And this is a period of time where that can't be reused for any other outgoing connections. It's partly a safety mechanism. If there are latent packets still flowing to that port, that port's not going to have been given to a different process, and they're not going to get packets they're not expecting. But this does present a problem. If we do this repeatedly and quick enough, then we're putting more and more of these ports into this time-wait state. And there is a limit to the number of ports we have. There's around 16,000 on Windows, which sounds like a huge number. But if this is one action method, this could be a large API that's got many tens or hundreds of action methods. They could all be making some kind of external calls, or many of them could be. So this could add up very quickly. And what we're going to run into, or what we may see in that scenario, is a socket exhaustion exception. And this is the situation where the OS basically puts its hands up and says, no, I can't give you an outgoing connection at this time. Try again later, maybe. And obviously that puts a compromise on what our service can do. And there's likely to be some performance issues prior to getting to that upper limit. And this may also compromise other services running on the same box. If you've got other things that aren't even your processes that need to make outgoing connections, if they can't get a socket, they could also have problems. So we need to start thinking about how and when we do this. So just to illustrate this is, I just took that code and stuck it in a tight loop 20 times. And you can see on the left-hand side, I've got 20 different ports that were all open to the same IP address, the external address, and they're now sat in this time-wait state. And they're going to sit there for 4 minutes, totally sort of bound up. I'm never going to expect to deal with those packets or make any further calls, but the OS can't release these for a while. So, presented you a problem. I should probably give you a solution. And up until .NET Core 2.1, there wasn't a one-size-fits-all solution. The best recommendation was not to keep disposing of the HTTP client, which means that you keep the handler chain and the connection pool that you had available, and you just keep reusing the same connections. So how could we do this in some code? So we'll just take a look at a very trivial way we might apply this. So I've got a startup class here, which is a feature of ASP.NET Core applications. We've got a configure services method where we add things into the dependency injection container. So one thing we could do is just add a singleton registration for the HTTP client. And now, whenever we need that, we can call it from DI. And the first time it ever gets asked for, we'll get a new instance. But thereafter, that same instance with the same handler chain and the same connections can be returned. So if we were to update our controller, we would inject the HTTP client that we need from DI now. And then we have to adjust the action, obviously. So we don't need to create a client or dispose of it. But now I run into this problem where previously I was setting the default request headers on the client. And this is to make sure that those headers apply to every request that goes through the client. Now, in this particular example, I'm only making one request, so we can solve this quite simply. But the reason we need to watch out for this kind of code is while HTTP client is thread safe in terms of its methods, and you can share this thing around in a singleton fashion, the properties on it aren't thread safe. So if you go changing these, if there are other requests in flight or about to be in flight, you may be affecting the headers that are on the client, and all sorts of bad things could happen, basically. So what we're going to do in our code is we'll just change to doing this as per request headers. And the only downside here really is that every time I'm calling the GitHub API, these are required headers. So everywhere I'm doing calls to the GitHub API, I have to remember to set these per request. And if these were to change, I probably have lots of places in my code to update. So not necessarily ideal, but it will work for now. And then the final thing is we would just change to using the injected HTTP client. And so pre 2.1, this was kind of the recommended solution that you would want to apply. But there's a problem. Now what we're doing is we're saying, well, keep these connections, hopefully, alive for the life of the application, potentially. Keep reusing them for all of the subsequent requests. So the first time we make the request, we're going to do a DNS lookup, and we're going to get the IP address of a server. And then we just can keep using that connection for future requests. But we don't know that there couldn't be a problem on that downstream service. That server could go away. And we now are going to not fall over as quickly as we'd want to necessarily. More specifically, if the downstream service is doing something like blue-green deployments, typically you'll have a production and a staging instance, possibly both web-facing at the same time, and it will just be purely DNS that's directing people to the correct production instance. If we keep our connections open forever, we're never refreshing our DNS information, we're never getting updates. So if that system does a swap of those slots, essentially, by changing DNS and does a new version, we'll still be talking potentially to the old one. So this it's a bit more nuanced problem, and whether you'll actually run into it or not, it depends on what you're talking to. We ran with a sort of essentially a singleton HTTP client approach quite happily for a long time. So it is a problem, but it depends on your scenario, how big a problem. But there were a couple of things being done in 2.1 that meant that there were solutions being addressed. So the ASP.NET team have been working on a solution. And as we'll see later, the .NET Core team are also working on some things in HTTP Client that make this better too. But we'll talk about HttpClientFactory because it solves not only that problem, but it brings a lot of other gains. So one of the things it's going to do as its job is it's going to manage the lifetime of those handlers. And as a result, it's managing the lifetime of the connections, essentially. So by default, what it's going to do is every time you ask it for a client, it will give you a brand new one, but it will attach either, well, if possible, an existing handler chain. So if it's got a handler chain that hasn't yet expired with existing connections, it will hand that to the client and it will use those connections. Those connections basically, by default at least, swap every 2 minutes. So you get the kind of best of both worlds. The connections aren't being constantly recreated and put into this time-wait state, but we're also updating often enough that we are picking up DNS changes. And that's configurable. If that's too long or too short for your scenarios, you can adjust it. Some other nice things about the Client Factory is that you can logically define configurations for different HTTP client instances you may need. So if your service talks to multiple other services, you can define different configuration for each of them that makes sense for those scenarios. That might be different things like different headers and things you need to send, but it could even be different ways that you deal with transient faults for those systems, different cross-cutting concerns you may want to apply, and we'll see how we can do that. It helps codify the concept of outgoing middleware. So outgoing middleware is really just using delegating handlers, which have been around with HTTP client since it was first released. But adding them into the chain was a little bit of a pain. With HttpClientFactory, they've made it very easy to do it in a kind of fluent way. It also integrates with that library called Poly that I mentioned, so we'll see how that can be useful for transient fault handling. And they added in some initial work on some improved diagnostics in logging in terms of the amount of logs that were generated, timings of requests, and you can even log out headers and things if you need to in tracing situations. So let's convert the code we have. What we'll do first is we'll do the smallest possible change, because this is the kind of thing that if you're having to make changes to your application, you don't want to have to do too much too fast. So let's just do the bare minimum. So the first thing I'll do is I'll get rid of my singleton registration, and I'm now just going to call add HttpClient here. This is an extension method on the iService collection. It's available if you've got the Microsoft.extensions.http NuGet package pulled in. And if you're using ASP.NET Core 2.1, you will have that. It's part of the app meta package, so it's automatically available to you. If you're on .NET Core, but maybe you're doing a console app, you would just need to pull that library in. And now this will have registered into DI the HttpClientFactory feature for us and some of its subsequent sort of moving parts. So now we can update our code, and we're going to make some changes here. So the first thing we'll do is we'll inject, instead of HttpClient, we'll inject the IHttpClientFactory itself. So now we have this opinionated factory that can give us instances of HttpClient when we need them. And then obviously, why is that not moving on? There we go. And then we obviously just need to change this to use a client that we've created through the factory. So we'll call factory.createClient, and now we have a new instance HttpClient, potentially with an existing handler chain, maybe not. So the connections will be managed for us by that sort of feature. And then we can just use it as we were before. And that's kind of the smallest possible change that you could do to an application to kind of start getting going with this. So that's the sort of getting started piece, but where the power starts to come is in this logical configuration concept that I mentioned. And there's kind of two ways of doing it. The first is named clients, so we'll look at those first. So the concept here is we're dealing with a downstream system, and we want to provide some kind of settings that are specific to that downstream service. So in this case, we've been working with the GitHub API, so we'll define a named client that's got settings that are specific for dealing with GitHub. Now, I'm defining this here in this method, but you can chain these, or you can create multiple registrations for more than one named client here. So you just keep calling add HttpClient with the different clients you want to add. And that's kind of the idea of it, really. If you've only got one, it's probably less useful. But as you add more and more different downstream services you want to talk to, being able to provide this configuration is handy. So the overload now takes a name, which is just a string. I'm just going to call this GitHub. And this is optional, but we can provide a delegate here that allows us to configure the client before it's returned from the factory. So the HttpClientFactory will create a new client with an existing or new handler chain as necessary. And then before it hands it back, it can run this delegate, which means we can now configure it with things like the base address and default headers for talking to GitHub. And this is safe to do because the clients that we get, or the HTTP clients we get back, are transient items. They're intended to be used short-lived periods of time. And so we can set them up ready to do the types of requests that we actually want to do here. And this is nice now. I have a central place where this configuration lives, and as you'll see in a moment, it means that I now will reduce the places in my code where I'd ever have to make changes if these headers change, for example. So in the controller, we do have to make some adjustments. First, we were talking to the full URL where we expect a base address now on the client we're going to use, so we can shorten that to just the path that we want to talk to. The per request headers we were setting, well, we can get rid of these entirely because now we're going to expect to get those set on the client we're going to be asking for in a moment. And then finally, when we want to create a client, we can provide the name of the named client we want, in this case, the GitHub client. And now we get back a client that's pre-configured with the right sort of handler management, and we've already simplified our controller code a little. So this is a good starting point, and this is sort of a nice way to get going with some of the logical configuration. We'll keep building on this, but before we build on it, I want to look more at type clients. And this is my general preference when you're dealing with HttpClientFactory. A typed client basically lets you build an abstraction around the processes of dealing with a downstream service. So rather than having to have code that's actually making HTTP requests to a downstream service scattered across your code base, we can start to centralize this in one typed client that knows how to deal with, say, a particular service. You use methods in there to encapsulate the types of calls you want to make or the types of data you want to get from it. And internally, then you just have the implementation that's necessary to go and actually call the endpoints and get the data. So to define a typed client, we just create a class. There's nothing special about this class. I've got an interface on it, and that's optional. I choose to use an interface because this means that when I start injecting this later on, it will be really easy for me to mock this in unit testing and give different responses from these methods. So I've just got a class. The only real special thing about it is that it accepts a HTTP client in its constructor. And this is going to be provided by the HttpClientFactory feature when it's giving us this typed client. Now, in this case, what I'm doing is I'm configuring my client in the constructor. So I'm doing the base address and the default headers here now. This becomes a bit of an optional preference, really. You could still do it in the original approach where we did it as a delegate when we register the thing. But I find that kind of clutters up the startup class a little. And also, this now is a typed client that's for dealing with GitHub. So this feels to me like the logical place where these kinds of settings live in my application. So this is a preference I have, is to just do it in the constructor. And then I'm going to create a method here. And this method sort of abstracts the functionality that we were intending to perform. So in this case, it's getting a particular list of repositories from the ASP.NET organization and returning, a bit of a fake domain model I've got here, but an enumerable of GitHub repo. So this now is just the code that we had before, really, to make the HTTP request and handle the deserialization. So now we have a type client defined. We'll need to register this. So in the configure services method, I'm going to get rid of the name client just so that we don't run out of space. I'm going to switch to using the typed client registration. Maybe. There we go. And this one basically takes generic arguments. So in this case, because I'm using an interface and I want to have a service type for this in DI, I've got the interface and then the actual implementation type. So now I've registered a typed client with DI and with the HttpClientFactory feature. So now I can actually switch my code to using it. So in my controller, I'm going to switch to injecting now the GitHub client. So now I'm injecting my specific sort of abstraction around talking to GitHub in this application. And now I've got the GitHub client, we can make some quite significant changes here. Previously, we were dealing with sending a request, getting the response, deserializing it, all inside the controller action. And another sort of preference of mine is that I keep my controllers quite lean, and I keep them doing the responsibility of a controller, which is really kind of validating inputs, coordinating, getting some data, and then returning the appropriate response type. This is a bit of noise I don't tend to like to see in a controller. And now that we've abstracted it away, we can just change the code to actually call our kind of GitHub client abstraction that we've created. So the controller's got simplified. It also means that any other places that want to do the same activity on that endpoint can just get the GitHub client and call a known method. I've written this code once. I'm not going to scatter this all over the place. And so now we've moved over to using the typed client feature. So the next thing I wanted to touch on is this concept of outgoing middleware. So again, it's a bit like the ASP.NET Core middleware pipeline coming in, but just for outgoing requests. So at an abstract level, when you send a HTTP request message, it goes out through HttpClient, trundles over the internet somewhere, something gives us a response, which comes back into us through the HttpClient as a HTTP response message. And that's typically how we interact with it, and that's the kind of thing we see. Under the covers, we've got that HTTP message handler chain, and I've simplified this for the point of actually fitting it on a slide. This is dependent on a lot of things like the configuration you're using, whether you're going through proxies or not. The handler chain will kind of configure itself appropriately. But at the kind of top level, you've got the HTTP client handler, and at the other end, which is making the actual network connection and sending packets over the wire, we've got the SocketHttpHandler. So these handlers then are responsible for actually taking the HTTP request message and translating that into the bytes that need to go over the wire to make a suitable HTTP request. And then it takes the response back in and then retranslates it to that object model that we have, the HTTP response message. Now, with this pipeline, the nice thing is we can insert our own handlers. We can add additional handlers into this chain that do whatever we want them to do. They get access to the request on the way out and the response on the way back in. So on the way out, you may do things like check the headers and validate that specific headers are there, or transform some headers. You may even talk to an external identity server, get an authorization token that needs to be attached to those headers. And then on the way back in, you see the response. And again, you could potentially mutate that, or more likely, you'd maybe make some judgments on the type of data you've got and whether you need to cache it or log it out to some system that you have. So when you've got these in the chain, this means that now the request and the response flow through this whole chain in order. And a bit like middleware in ASP.NET Core, you've got to get your order correct. But now you have this place to apply cross-cutting concerns. And we do that with a delegating handler. So a delegating handler is basically another class that we're going to create. We have to derive from the abstract base class, which is the delegating handler itself. And in here, I can inject a service if I want to. I'm injecting this iMonitoring service that we're going to use for this example. And then the main thing is that we override the send async method. So this takes a HTTP request message, and then we'll at some point return a HTTP response message. And so very much like middleware, this is going to pass the message on down the chain at the appropriate point when it's ready to do so. So here we could do some work before the request is passed on. I'm not in this example. So what I call is base.sendAsync, which will pass the request on to the next handler in the chain. And that will eventually give us back the response it got. And then at this point, before I pass it on completely, I'm actually now logging that out to a monitoring service. And now I've got this place to do this monitoring of the status codes to some kind of external metric system. So to register this into my application, I can take advantage of some of the other configuration on HttpClientFactory. So when you do add HttpClient, you get back a HttpClient builder. And on there, you can fluently configure other things about that client. So one of the things I can do is call add HTTP message handler, and then just give it the handler type that I want to add to this. And now anything that goes out through my typed GitHub client is going to also flow through that handler automatically, and it's all wired up for me. So that's a really powerful and easy way to add these cross-cutting concerns to the right clients as we need to. One other caveat and important point is you do have to automatically remember to register that as a transient service in DI, which still annoys me to this day because it could happen inside that method, but it doesn't. So just something to watch out for. So I want to move on to Poly. I don't have time, unfortunately, to kind of go deep into what Poly does or how it does it. But basically what Poly is a library that allows us to handle transient errors or faults in the system in certain situations. So it's a resilience library, and it gives us a bunch of ways to build what they call policies. And these policies basically take effect for a given scenario, a given situation. So you say, execute this piece of code, and if X happens, do something else. So in this case, it might be if the response you get is a HTTP request exception or a 500 type error or maybe a timeout, maybe that's a transient HTTP fault that we could benefit from doing something with. The example that's most useful is like retrying. If we get a transient 503 type error, the servers aren't available, maybe it will recover. Maybe it's just switching over, maybe some load balancing is happening. So maybe it's worth retrying that request a few times before we give up on it. So a retry is a good way to just automatically make sure that that request gets re-executed for a certain number of times, and maybe that will solve some of your problems. And there's all sorts of policies that, I could spend a whole talk on these, but circuit breakers would let you release pressure on a downstream system, for example. If it keeps failing, maybe stop sending requests for a period of time. You might apply timeouts around through this. Fallbacks are quite useful. So if you've retried and you can't get a good response, maybe you want to provide some kind of default response. And you can even wrap things with caching. And you can chain these together. It's very typical to chain multiple policies together, either manually or as a policy wrap, which lets you put like very complex logic together. So let's look briefly at how we would use Poly in our codes today. It's kind of a delay, right? So again, on the HTTP client builder, we've got other methods we can call. And in this case, I'm going to use the add transient HTTP error policy. Now, this isn't automatically available because it depends on Poly, which is a third-party library. Microsoft don't include this as part of the app meta package for ASP.NET Core. So you do manually need to reference microsoft.extensions.http.poly, and then you can just start using this. And basically what it does is it sets up in the background a policy that's part built, and it's built ready to handle any of those things I've already talked about that might be a transient HTTP fault. And then you say, well, here's what I want you to do in that scenario. And in this case, I'm doing a very basic wait and retry. So I'll retry up to 3 times with a small delay. And that delay is going to exponentially back off between retries just so that if that downstream system doesn't immediately respond, maybe it will after a second. But if it hasn't after a second, give it a little longer the next time. And this allows us to ensure that anything that goes through this GitHub client will try those 3 retries if it gets any kind of transient fault. And I don't have to code that anywhere into my own code base now. So some other tips and tricks, things to watch out for around HTTP generally. Take care when you're handling response content. So far in our code, because we need to deserialize this object, we take the content, we read a string async to get the JSON string, and then we can pass that into JSON.NET. And this looks quite reasonable. The downside of this is I'm allocating a string. And if you're in Ben's talk earlier, don't allocate if you don't have to, and you make the GC's life easier. This string is kind of wasteful. It's just a transport, in this case, into the JSON.NET method here to deserialize it. But JSON.NET works with streams quite happily, and we could just use the content stream to actually deserialize the object without this intermediary string. Now, if this is a small string, if this has happened often enough, then it might still add some GC pressure. But if it's a really large JSON content you're getting every time, you could be allocating something on the large object heap every time your method's called. almost needlessly. So this is something to watch out for. And also, what if a third-party actor gets in and compromises a downstream service? One of the things they could do to really screw you up here is send you back a 3 gig response that you try and read as a string, and then you've just used a lot of memory in your app. So this is a thing to watch out for, and it's easily solved. You could use the JSON APIs directly, and JSON.NET, sorry, and do the stream handling directly. It's about 10 lines of code, I think, on their site. They give an example. The easier option is use this convenience method, read as async. And what this does is it does that behind the scenes, but you just give it the type you want. And so it will use the streaming APIs and avoid one unnecessary allocation. So this is just quite convenient. It is available if you're using ASP.NET. By default, the package is referenced, and I've written it down here. It's ASP.NET.WebAPI.client. If you need to bring that into a non-ASP.NET application, you'll get that extension method on the content there. So another thing to think about is handling errors. We've touched on transient errors. But there are other errors that we haven't dealt with here. We may get a response, but there's no guarantee the response is a success response. And here I'm blindly planning to deserialize some content. But if this is a GET request, I might get a 404. There may be no content, and this may actually throw an exception. So we should always guard. We shouldn't trust that one endpoint that was there yesterday is still there today. So one thing we could do is call ensure success status code. This will check if the status code is in the 200 range. It will just return. Otherwise, it will throw a HTTP request exception. And then in this case, our caller would have to probably catch that, I guess. I don't really like that. I prefer to kind of encapsulate that in my typed client. And there it is. So one of the things we could do is just conditionally return a response by using the isSuccess status code to decide, okay, well, if it's successful, we will deserialize. Otherwise, we'll just return some kind of meaningful default for this particular typed client. Next thing I want to get into is handling cancellation. So cancellation is a feature really of async await, and we can take advantage of it because HttpClient is fully async await. And basically the idea here is we don't want to be doing work we don't have to. And in the scenario that I'm showing you specifically here, it's entirely possible we're making a downstream request on the basis of someone hitting our server with a request, but they might give up or go away, or they've clicked the wrong link, or they've cancelled their request. So as soon as they cancel, we kind of want to stop doing anything that's resource intensive on our side. One of those things is sending a request and then later deserializing it. We might be able to avoid that. And we can just use the standard approaches of async await to achieve this by bringing in a cancellation token into our method here. And then we can do a few things with that. This isn't a full async await talk, but one option we could have is just to throw if cancellation requested at this stage. This is before we're trying to send the request. So if someone cancelled really quickly, which is possible but not likely, but at least at this point we're not trying to send the request. And if there are no connections already open, we aren't even opening a new connection. We're not trying to do anything resource intensive if they've given up at this stage. Further to that, we can pass the cancellation token along, which is kind of a good practice in async await, to any method that async and accepts it. So this means they will hopefully do the right thing downstream as well and cancel at an appropriate point. So the main sort of tricky thing here is, well, we're calling this from an action method on a controller at this stage, so how do we get a cancellation token that's representative? And it's a fairly unknown fact, at least in my polls, that you can actually just ask for a cancellation token as a parameter of your action, and when the action invoker in ASP.NET Core invokes that action, it will inject you a cancellation token tied to the current request it's handling. So at this point, you can get that signal. If someone changes pages or cancels an API call, you'll get the signal through from Kestrel that it's been cancelled, and now we can just propagate that down. And that's a feature. It's a very long delay. That's a feature of ASP.NET Core. So that's worth taking advantage of in these kinds of scenarios. And we've used this practically. We've got a system at Madgex that's one of the things when we get a request in, we're going to call an Elasticsearch query that could take up to 30 seconds in certain scenarios to run. It's quite a heavy, intensive piece of work. And then when we get that, we've got a very large data set we're going to work with in memory. So if we can accept these cancellations through from our callers, we can avoid doing that kind of work. And it's very typical of our users. We found that they'll click a link on the UI, and then they'll change the report they're viewing, and they'll click a different one. And so that previous piece of work that could be quite intensive is still going on in the background, and just no one's ever going to listen to the response. So this is kind of practical stuff we've applied and saved ourselves a little bit of overhead. So I couldn't really do this talk without answering this question, because it's probably the question that everyone sort of comes to. When should I dispose of these things? And I've kind of hinted at it so far. So it's probably good that I give you a good answer, and the good answer is it really does depend. I will give you some information that can help you make an informed decision on this, but a lot of this is reliant on implementation details that may or may not change in the future. So it's always worth kind of considering how this stuff works. As I say, I've blogged about this stuff, and it's really easy to go and look at the CoreFX source code if you really want to kind of check this stuff and see if there were any significant changes between releases that might affect the information I've given you today. The general answers are, if you're using HttpClientFactory, disposing of it, of the HTTP client itself, has no effect, because the HTTP client isn't the only thing that's got a reference to the handler chain. The handler chain is being managed by the client factory, and so disposing of HTTP client just is essentially a no-op. It's not really practical. The main thing you want to do there is avoid holding on to the HTTP client for an unnecessary amount of time. You're meant to treat it as a transient item that you need temporarily, because the client factory should always give you a fresh one each time to make sure you're refreshing those connections. If you're not using HttpClientFactory, then before 2.1, the advice generally was generally never. As I said earlier on, using a singleton instance, for example, will keep those connections being reused. But you do then run into the potential for the DNS issue. Since 2.1 in .NET Core, the SocketHttpHandler that's now in place does actually cycle connections for you as well. So you've actually got an additional safety mechanism there, and we'll talk about that handler in a moment. The other things that implement iDisposable that people give less consideration to is HTTP request message. So in this case, when should you dispose of that? The answer is it only has an effect if you're sending a stream content, so if you're sending it a stream as your content, and what it will do under the hood is dispose of that stream when the request has been sent. So you need to decide if that's the behavior you want. If you own the stream and you're sure that you're done with it, you probably could use that mechanism. But if someone else has passed you that stream, you might not want to make those kind of judgments in your particular action, in your method, sorry. For the HTTP response message, that also implements iDisposable. And the answer there is that generally disposing of that will have no noticeable effect, but there is one specific case where it's really important that you do. And you will know that you've done this, so I'm going to show you the code in a moment. But the safest answer as a general rule would be, well, maybe always do it, and then you're never going to run into the risk. So the particular case I'm talking about is this one small modification I've made to the code that we've got so far, which is this option that I'm passing in. So by default, HTTP client will completely buffer all of the content into a memory stream when it gets a response back. And it does this so that it can release that connection back to the connection pool as quickly as possible, and it minimizes the number of connections that need to be in use. That's a great feature, but sometimes if you're not going to always deal with that content on the condition of certain headers, it makes sense to basically say to it, actually, just do response headers read, get the headers back, don't pre-buffer the content yet. I will decide if I'm going to access that content and what I'm going to do with it. But in this scenario, what it's doing is keeping that connection essentially waiting until we said we're done with it. And so in this scenario, we need to dispose of the response message to signal that we're done with the connection, and it can go back to the connection pool. If you are doing this, then the safe way to do this is in a try finally, because this ensures that whatever happens here, even if we've thrown an exception reading this content, we make sure that we definitely do dispose of the response when we're done with it. And this is sort of a typical pattern that you might want to apply. So if you're messing with that option, definitely do this. If someone might come along later and mess with that option, maybe it's best just to do this in the first place and be safe. And it's a bit of noise, but maybe not too bad. So moving on, and we're sort of getting towards the end now, I just want to talk about the last few features. So I hinted at SocketHttpHandler a few times. So this was introduced in .NET Core 2.1, and it's the default in 2.1. And this is a new way of the HTTP client implementation, really, making its HTTP calls. So previously what was happening is the HTTP client and the handlers were deferring down to OS-level APIs they could call to actually to form and send the HTTP requests. So that was WinHttp on Windows and libcurl on Linux. There were a few issues with that. One of them was that the performance wasn't really very comparable. Linux was a lot slower. And it's also a little bit harder to maintain because we're reliant on sort of higher-level APIs in the OS. So what they've done in 2.1 is they've rewritten this sockets HTTP handler, which is basically fully managed code to build and send the HTTP response or request and the response and deal with it all. And at the OS level, all it's asking for is a raw socket. So it's just dealing with the network sockets to actually send the data. So this means that they're able to keep this code more consistent. The behavior is a lot more comparable now. Linux is closer to Windows. It's not quite on the same par, but it's a lot closer. And generally, they can make sort of performance optimizations, like things like applying span and all of those new features that Ben's talked about and other people will do through the rest of this day, can be applied to that managed code to make it quicker and more efficient. So it's enabled by default. The reason you may have wanted to turn it off in 2.1 is it doesn't support HTTP2. So that could be a problem for what you're doing. And then you can just switch it off with an environment variable if you wanted to. So what's coming in 3.0 are a few other changes. Nothing major, but the big one I think that it's worth being aware of is that HTTP2 is somewhat supported now with the socket's HttpHandler. The primary reason for that support is to make sure that the gRPC scenarios that the ASP.NET team are working on can work, because gRPC is gRPC remote procedure calls. These remote procedure calls use the protobuf sort of binary format to do efficient server-to-server communication, and the transport for this is HTTP2. So for the team to be able to implement this with ASP.NET Core, both from the client and server perspective, we needed the HttpClient piece at least to be able to talk in HTTP2. So this is kind of the reason for that. Because of that, the HttpClient now includes a version property on there that you can set. So you can set this once per HttpClient. So in the named or typed client scenario, you could switch this on conditionally for certain clients that need it. By default, it's 1.1, but you can switch to 2 if you want to try it. Another smaller change is that TLS 1.3, OpenSSL 1.1.1 have been introduced and supported now. So on Linux, where this is available, it means we've got a slightly reduced connection time and improved security features coming there. When Windows and Mac OS support these things, hopefully those will light up as well. And now I just want to sort of summarize. There's a lot of information I've tried to flow off in 45 minutes. As I say, a lot of this I have blogged about, so you know, if you want to digest this in your own time and kind of look at more deep code samples, please do check those out. But the first piece of recommendation is to use the HttpClientFactory. Even if the socket's HttpHandler is managing connection lifetimes for us now in its connection pool, all of the other features like the logical configuration through those type clients that I particularly like, the integration with Poly, the ease of applying the cross-cutting concerns through those handlers, I think are all compelling reasons to start thinking about applying that if you're building out microservices that are communicating with one another. One of the things I do very often now is when I build a new sort of microservice in our environments, I build a small SDK library that people can just consume via NuGet. And all that really is a wrapper around building a typed client for them that implies all of these features and gives them an extension method on iService collection so they can register this. So with one call, they kind of add this API surface in that they can easily deal with, and I handle all of the stuff about what do I want to do in certain transient failure scenarios. So Poly is really powerful. I do recommend people check that out. Their wiki has a great deal of examples about how to use all of the different policies, both individually and together. So I do recommend kind of reading through those and seeing where they're applicable. I chain usually 3 or 4 different policies together to give me a very nice kind of set of conditions that will handle most transient issues, even to the point of giving me a fallback if nothing else has worked. Do be aware of just or taking the content as a string via read as string async or the get string async methods. That's an unnecessary allocation in a great deal of places. The only real compelling reason to do it is for debug purposes, where you want to see the JSON string and try and work out what you were actually sent. Maybe if debug it around it, or put it in temporarily, but just make sure your code reviews are checking for it, really. Expect for and handle errors. Don't just assume everything's going to work continually and you'll always get the same responses from things. Pass those cancellation tokens through your application to get cancellation support of these methods. And hopefully, with all of those pieces of advice, you can kind of go and use HTTP in a new light, update your code bases, and make sure that you're doing everything in the most sort of good way possible. I'll leave a few resources up in a second. So these are my details. You can plug the website once again. But the more important ones are these resources. So these are some specific blog posts on my blog that I wanted to bring up. These ones are the ones that look at the internals of HTTP request message, response message, and HttpClient to understand what the behavior is when you dispose of it. So that kind of gives you a full rundown of the current behavior at least. The blog post by the ASP.NET Monsters was one of the first ones I read that talked about the issue of software exhaustion. Yeah, it's the sort of famous post that was released that made everyone panic because it really illustrated that problem. The documentation is pretty good for HttpClientFactory. which is a bit big-headed of me because I helped write most of it, but I've tried to distill all of the stuff I found in the blog post down to the documentation. And then the GitHub repo for Poly there, as I say, they've got a really good wiki that you can go and explore, and great examples of how and when you would use those in your applications. And so, yeah, I think that's pretty much it. So I'll go back to that slide and say thank you very much for your attention. I've got no idea how we're doing on time. We're on time. That clock's wrong. So there isn't actually time for questions. I'll let Mark start getting set up for his talk. But if you want to find me sort of over to the side afterwards, I'm happy to answer questions one-on-one or as groups. Thank you very much.